Okay, so for today's deep dive, I want you to just imagine this for a second. You've got this huge perimeter to secure maybe a giant warehouse, critical infrastructure, something like that, but you can't build a physical wall.
Right.
So we're diving into exactly that. Perimeter security. Specifically, we're looking at a piece of tech called the NTI E-PBD-DO190 dual photobeam detector. The real mission here is to figure out how these things create a totally invisible electronic barrier without, being constantly fooled by nature.
And the scale of this solution is what's really fascinating. The DO190 model protects up to 190 feet outdoors.
190 feet.
Yeah, and the series scales all the way up to the DO390, which can secure 390 feet. That's almost a football field.
That is just a staggering distance for, what, an invisible tripwire? So that brings up the immediate question, right? How on earth do you set up an invisible wall over hundreds of feet without an alarm going off every single time a bird flies through or a leaf falls?
Yeah.
It just seems like a fundamentally impossible problem to solve.
It does, and that's where the really clever engineering comes in. The core idea is the use of twin infrared beams.
Twin beams, okay, so not just one.
Exactly. It's not just about breaking a beam.
Yeah.
An object has to interrupt both beams almost at the same time. This is really the key to telling the difference between an intruder and just noise.
I see.
A falling leaf, a small bird, it'll probably only break one beam for a split second. But an intruder is big enough and slow enough to break both.
Yeah.
And that gets paired with, lensed optics and a special sunlight filtering case, so it's also incredibly immune to rain, snow, mist, that kind of thing.
So that logic requiring two simultaneous breaks, that's the real insight. That elevates it from just a simple sensor to a properly smart system. But let's talk about durability. I'm looking at the specs, and the operating temperature range is, well, it's extreme. -13 to 131 Fahrenheit. You mentioned weather, but what about that anti-frost system? How does it handle temperatures down to -25 Celsius without just draining power or, creating heat that messes with the beams?
That's a great question. It's actually a very targeted system. It uses these tiny low-power heating elements built right into the housing.
Okay.
Their only job is to keep the face of the lenses clear. It's not about heating the air or the unit itself. It just prevents condensation and ice from forming, because if the lens is blocked, the system is blind.
So it's purely about optical clarity. That makes sense.
And that minimizes downtime and, maintenance calls in cold climates.
Okay, so installation. This sounds tricky. Over such long distances, alignment must be a nightmare. Let's say you're setting it up. The system uses a built-in laser. Doesn't that sort of broadcast to anyone watching exactly where you're building your invisible wall? Seems like a tactical problem during setup.
It would be, but the laser system is temporary. It's a tool, a necessary one, to get that precise, minute alignment over hundreds of feet.
Oh, okay.
The second you got it locked in, the laser is switched off, and the barrier becomes truly invisible again. And what's more, if you need to create, say, layers of security with multiple units close together.
Right, you'd worry about them interfering with each other.
Exactly. So they have 4 selectable beam frequencies you can switch between. That stops them from cross-talking and causing false alarms among themselves.
That's a huge advantage for creating really dense security zones.
Yeah.
So, okay, it's set up, it's aligned. How does it actually talk to the command center? What's the brain receiving the alert?
It integrates directly into an ENVIROMUX system, which is NTI's own monitoring platform. That system also powers the unit, which is very convenient. It connects with standard wiring or even just a network cable.
Simple enough.
And importantly, it has an NCNO alarm output. That just means normally closed or normally open. It's a technical term, but what it means for an installer is that it's compatible with basically any security panel you might already have.
So it's versatile.
Very. And the little LEDs on the unit for power and signal strength mean a technician can see what's wrong right away without having to guess.
So to pull this all together, the key takeaway here seems to be that reliable, high-end perimeter security really depends on this specialized engineering. It's this delicate balance between achieving extreme range and having really sophisticated filtering those twin beams, the optics, to mitigate all those false alarms.
Exactly. And that actually leaves us with a really interesting final thought for you to consider. Think about the power consumption. The biggest unit, the DO390, it draws about 88 millilate to run everything, including that anti-frost system.
Which isn't very much.
It's a tiny amount of power.
Yeah.
But it's continuous. It's always on. So the question to mull over is this. How does that constant, relatively small power draw relate to the strategic need for an always-on invisible defense that literally never sleeps? that constant tiny draw, that's the price of continuous certainty.